It's amazing, isn't it? Like even years into this whole COVID-19 thing, the
Yeah.
amount of information about the vaccines, it's overwhelming. You practically need a life raft to navigate it all.
Oh, absolutely. It's a tidal wave of data, opinions, everything. What we really need, I think, is that solid, large-scale research,
Yeah.
something that cuts through all the noise and just lays out what the data actually says about vaccine safety.
Right, like give us the real deal. And that's exactly why this deep dive we're doing today for you, the learner, is so important. We've got our hands on a really significant study, this major piece of multinational research that was published in Vaccine Journal back in 2024.
Ooh, that's a big one.
Yeah, and this isn't just like anecdotal stuff or quick takes. This is a deep, deep dive into adverse events.
Those eight ESIs we always hear about.
Right, adverse events of special interest following COVID-19 vaccination. And get this, it covers almost 100 million people
Wow.
across 8 countries.
That's a huge, huge sample size.
It is. So our mission today is to really unpack this study,
Sounds good.
focusing on the strength of the evidence and what it all means for our understanding of vaccine safety, cutting through all the hype.
Exactly. We want to go beyond just what they found, right? Like how solid were their methods? Why should we care about this particular study?
Exactly, yeah. It's about the quality, the weight of this research in the grand scheme of things.
Because it does have implications globally, right?
It really does. So first things first, let's talk about the scale of this thing. 99 million people.
That's mind-boggling.
Right. It's basically the population of a whole country. They pooled data from 10 different sites
10.
across 8 countries. Argentina, parts of Australia,
Okay.
Canada, a couple provinces there, Denmark, Finland, France, New Zealand, and Scotland. And the time frame was pretty extensive, generally December 2020 to August 2023.
So a good chunk of time to observe what's happening.
Yeah, a substantial window for observing, potential outcomes.
It makes you appreciate the collaboration behind this, right? Because to collect and harmonize data from that many people across all those different places and over that length of time, that's no small feat.
Not at all. And think about it. Different healthcare systems, different ways of reporting things.
Wow, all those nuances you have to account for.
Exactly. But, that diversity actually makes the findings stronger, I think. Because if you see consistent signals popping up across all those different settings, that's pretty compelling.
It is. It's like, okay, something's definitely going on here.
Yeah, exactly.
Yeah.
Now, let's talk about the observed versus expected analysis.
Oh, okay.
This is like a core method they used. And for the learner out there, it might sound a little technical.
Yeah, it can be a bit jargony.
But it's actually quite clever once you understand it. So
Yeah.
can you break it down for us, explain how it works and why it's such a powerful approach?
Sure. So imagine this, the learner. Before the pandemic hit, we already had years and years of health data, right?
Tons of it.
Tons. And that data tells us how often certain medical conditions just like typically occur in the general population.
Right, like what's normal.
Exactly. So that's our expected rate. Then along comes the vaccine rollout, and we start tracking those same conditions in people who've been vaccinated. That's our observed rate.
Okay, got it.
And the magic happens when you compare those two. You take those observed numbers, put them up against what we'd expect based on historical data. And this is important, adjust for things like age and sex because we know those factors play a role. That way, we can figure out if vaccination might be linked to an increased risk of something specific above and beyond what's already out there in the background, so to speak.
Right, it's all about context. It's not just about counting events after vaccination, but understanding if those events are happening more than they normally would.
Precisely. It's like, is there a signal here that's louder than the usual noise?
I like that analogy. Now, the study really zeroed in on what they called prioritized safety signals. These were instances where the observed versus expected ratio was greater than 1.5, and specifically, the lower bound of the 95% confidence interval had to be higher than that. Why 1.5? Why is that statistical threshold so important?
So that 1.5 mark, the learner, it's like a quality check, a way to make sure we're not getting excited over signals that might just be flukes. Because a confidence interval, what that tells us is a range of values where the true effect likely sits.
Okay.
And if the bottom end of that range, that lower bound, if that's above 1.5, it's a stronger sign that something real is happening. That the increase we're seeing isn't just random variation, it increases our confidence.
So it's like setting a higher bar for what we consider a real signal.
Yeah, exactly. It helps us filter out the noise and focus on the signals that are strong enough to warrant more attention, to suggest a potential link that needs to be explored further.
Makes sense. Okay, so armed with this understanding of how rigorous their methods were, let's dive into some of their findings. Specifically, let's look at the neurological stuff first.
Uh-huh.
What did this huge multinational data set reveal?
All right, so one of the clearest, most statistically significant signals they found involved the Chanox-1 vaccine, the AstraZeneca one.
Right.
They saw a prioritized signal for Guillain-Barré syndrome, GBS, after the first dose, and the observed rate was more than double what they expected, which is a pretty big jump.
Wow.
Yeah, the OE ratio was 2.49. And remember that confidence interval we talked about? It was well above 1.5, meaning it's a pretty robust finding. They also found a prioritized signal for cerebral venous sinus thrombosis, or CVST, again after the first dose of AstraZeneca.
And the OE ratio for that one?
Even higher, 3.23. Now, the fact that these findings are coming from such a massive and diverse group of people really strengthens the evidence for this link.
That's a key takeaway for the learner. We've had hints of this connection before, but this study really provides substantial data to support the link between the AstraZeneca vaccine and a slightly elevated risk of these specific neurological conditions after that first dose.
Yeah, I think that's fair to say.
Okay, what about the mRNA vaccines, Pfizer and Moderna? Did the study find any similarly strong signals for neurological conditions with those?
There was one interesting signal for acute disseminated encephalomyelitis, ADEM, after the first dose of Moderna. And the observed to expected ratio was actually quite high, 3.78. However, and this is super important to understand, the learner, this particular signal, was based on a small number of cases. Only 7 observed cases compared to 2 expected. So while statistically it meets the threshold, the small numbers make it harder to draw definitive conclusions.
It's almost like it raises a flag for us to investigate further.
Exactly. It highlights how even in a huge study like this, when you're looking at rare events, things can get a bit tricky to interpret. You might see a strong signal statistically, but you need more data, ideally, from other studies to really confirm if there's a true link there.
Makes sense. So it's not a slam dunk, but definitely something that warrants further investigation. All right, moving on. Let's talk about hematological findings. We already touched on CVST with the AstraZeneca vaccine. What else did they find in this category that met their criteria for a prioritized signal?
Well, aside from CVST, they did see an increase in the observed to expected ratios for some other hematological conditions, things like thrombocytopenia and immune thrombocytopenia, or ITP. And this was after various doses of both the mRNA vaccines and AstraZeneca.
Okay, so across the board.
Yeah, but none of them quite hit that 1.5 threshold for the lower bound of the confidence interval. So while there might be an association, the evidence wasn't strong enough in this particular analysis to say for sure.
Again, it emphasizes how important it is to have that clear statistical bar in place, especially when you're dealing with such a massive amount of data.
Absolutely. It helps you focus on the signals that are most likely to be real and not just random blips.
That's right, the real deal. Okay, last but not least, let's talk about cardiovascular findings. This has been a big area of focus, especially with the mRNA vaccines. So what did this very thorough multinational study tell us?
All right, well, the study did find some pretty consistent signals for myocarditis.
Inflammation of the heart muscle.
Right. Inflammation of the heart muscle after the first, second, and even third doses of both Pfizer and Moderna.
All the mRNA vaccines.
Yeah. And interestingly, the highest risk seemed to be after the first and second doses of Moderna specifically.
Interesting.
Which actually aligns with what we've seen in some previous research.
Right.
So this isn't necessarily brand new information, but seeing the signal emerge across so many countries in such a large study, well, it definitely adds more weight to the finding.
Yeah, it makes it harder to dismiss.
Right. So it reinforces what we already know, that myocarditis is a rare but possible risk, especially with mRNA vaccines. And this study helps us quantify that risk even more precisely.
And it also shows that even though rare, it's not just a one-off, right? This signal is pretty consistent.
Yeah, that's the thing. It keeps popping up.
Okay, what about pericarditis? Inflammation of the sac around the heart. Any signals there?
Yes, they did find prioritized signals for pericarditis as well, after the first and fourth doses of Moderna, and also after the third dose of AstraZeneca. Although it's worth noting that fewer people in the study had actually received a third dose of AstraZeneca, so that particular finding needs to be interpreted with a bit of caution.
Okay, smaller sample size.
Right. But overall, they did see increased OE ratios for pericarditis across all doses of all 3 vaccines.
So it's something to keep an eye on.
Definitely an area where more research and monitoring is needed.
Okay, so as we can see, this is a pretty complex picture. different signals for different vaccines and doses, really highlights the need for this kind of in-depth, large-scale analysis. But let's zoom out for a second and talk about the credibility of this research. Who's behind this study, and why should the learner trust these findings?
So this research was conducted by the Global Vaccine Data Network, or GVDN. And this isn't just some random group. This is a well-established, highly respected international consortium that focuses specifically on vaccine safety monitoring.
Their bread and butter.
Exactly. And the fact that the study involved researchers and data from 10 different sites in 8 countries. I mean, we're talking about some major institutions here, like the Statens Serum Institute in Denmark, the University of Auckland in New Zealand.
Yeah.
It shows you the level of collaboration and expertise involved.
Yeah, it's not a small operation.
Not at all. And to add to that, the funding for this project, for the C0VIS project, which this study falls under, came from the CDC. That's a major public health agency. And it speaks to the seriousness and rigor of this research.
Absolutely. And the list of authors on this paper is incredibly long and diverse, representing a wide range of expertise in geographic locations. That also helps minimize bias and increases our confidence in the finding.
Right. It's not just one perspective or one institution driving the narrative. It's a truly collaborative effort.
Okay, so beyond the impressive credentials of the researchers and the sheer scale of the study, were there any specific methodological strengths that make this research particularly reliable?
Yeah, a few things. First, they used a common analytical protocol across all the participating sites. This standardization is really important because it ensures that the data is collected and analyzed consistently, making the comparisons between different regions more valid.
Right, like apples to apples.
Exactly. And then there's the observed versus expected method itself. As we discussed, this is a very robust way to contextualize what's happening after vaccination.
And they adjusted for age and sex in their analysis as well.
Right, which is crucial. It helps account for those demographic variations that we know exist in how often these conditions occur.
So it's a very nuanced approach.
Yeah, they try to control for as many variables as possible.
Of course, even with all these strengths, no study is perfect. What limitations did the researchers acknowledge in their paper?
Well, they were very transparent about the challenges of doing a study of this magnitude across so many different countries. One of the main limitations they pointed out was the potential for heterogeneity in data collection and reporting practices between those different healthcare systems. Even though they had a common protocol, there might be variations in how diagnoses are made and recorded, which could introduce some variability into the data.
It's the real world, right? Things aren't always perfectly uniform.
Right. They also acknowledged that the vaccine rollout strategies varied from country to country, and that could potentially influence the observed outcomes. And finally, it's important to remember that this is an observational study. It can show us associations, but it can't definitively prove causation.
Right. Correlation doesn't equal causation.
Exactly. However, the strength of those statistical signals they found, combined with what we already know about the biological mechanisms involved in some cases, does suggest a likely link.
Okay, so lots of good data, but more research is always needed to confirm.
Always. Science is a process.
All right, so just to recap for the learner, the key prioritized safety signals identified by this incredibly robust and well-designed study. We saw strong evidence for an association between the first dose of the AstraZeneca vaccine and GBS and CVST. And then we saw signals for myocarditis across multiple doses of both Pfizer and Moderna, with a slightly higher signal after Moderna.
Right.
And then there was that potential signal for ADEM with Moderna, which needs further investigation.
That's a great summary, and I think it's really important to reiterate that while these signals were identified, and that's a good thing, by the way, it shows that our monitoring systems are working. These events are still rare.
Very rare.
And the overall consensus, based on all the data we have, is that the benefits of getting vaccinated against COVID-19 in terms of preventing serious illness, hospitalization, and even death far outweigh these rare risks.
And I think this kind of large-scale international high-quality research is absolutely crucial to maintaining public trust in vaccination. It shows that we're constantly monitoring, we're investigating even those rare signals, we're committed to transparency.
Absolutely. It underscores the importance of global collaboration in tackling these public health challenges, and it really does provide a strong foundation for making evidence-based decisions about vaccines.
So, the learner, as you process all of this information, as you think about this really monumental study, consider this. How does the sheer size and collaborative nature of this research, combined with those rigorous methods, impact your confidence in how we monitor the safety of medical interventions? And what does it tell you about the ongoing commitment of scientists worldwide to understanding and addressing even the rarest potential adverse events associated with vaccines?
It's something to think about, right?
It's,
Yeah.
yeah, it's important stuff.